Hello student, hope you are enjoying my general chemistry lectures series, and so far we have completed chapter number 4, and now it's time to start chapter number 5, which is thermochemistry. And thermochemistry is the study of the heat changes in the chemical reaction. If you remember, in the definition of the chemistry, that says chemistry is a study of matter and physical changes and chemical changes and basically properties of matter, and then energy associated with that one. So now this is the topic, or this is the chapter which is related to the energy in the general chemistry. And these two pictures are showing how energy is affecting, how much energy can work do. This is kind of blast of a old hydrogen aeroplane. And next is a sugarcane fields of the green energy. Basically sugarcane is a source of green energy. So, and in this chapter basically 9 topics we will cover. So the nature of the chemical energy, the first law of thermodynamics, and enthalpies of reaction, calorimetry, Hess's law, enthalpies of formation, bond enthalpy, and food and fuel. So we will see there are some new terminologies are here, and then how to understand those one and how to apply those energy terms. So this will be very interesting chapter for chemistry, for general chemistry in chapter 5, and I will be appreciate if you have any question or any comments. Please type your any comment or question in the my videos, and then I will try to answer your questions. Okay, so let's start chapter number 5. First topic. So let's start chapter number 5, which is thermochemistry. And thermochemistry is the study of the heat changes in the chemical reactions. So first terminology in this chapter is this chapter is about the thermodynamics. And now you can see there is one more term came, thermodynamics. So what is the meaning of thermodynamics? Thermodynamic means which is the study of the energy and its transformation. And chapter 1 is energy is a capacity to do work. So this is the technical definition of energy. It means the capacity to do work. And specifically thermochemistry is the study of the chemical reactions and the energy changes that involve heat. So whenever we do any chemical reactions, it requires some heat, or it exchanges the heat without either it require the cooling condition or heating condition. Some reactions require really huge transformation of energy. That is why thermochemistry is very important to understand. And there is a first law of thermodynamics is energy can be converted from one form to another, but it is neither created nor destroyed. So this is the first law of thermodynamics, which says that you can convert energy from one form to another form, but neither we can create nor destroy the energy. And for an example, to heat your home, chemical energy need to convert to heat. So we burn the gas, or we create the heat from the electrical energy. So we are just converting one energy form to another one. Another example is sunlight is converted to chemical energy in the green plants to make the glucose and food for us. And there are many more examples of conversion of energy. For an example, if this bike bicycle and guy is going on the uphill, so basically it is putting, or it is gaining more energy as it is going up, and once it will be have up in the hill, it has the highest energy, and when it will go down, it releases the energy which he has gained from bottom to up. So energy is the neither we can create nor we can destroy, just we can convert from one form to another form. So this was the definition of thermodynamics or energy for the first law. And then definition about the system and surrounding. What is the meaning of system and surrounding? The portion of the universe that we single out to study is called the system. Usually chemical, here the hydrogen and oxygen in the molecule. So you can see this container or piston which have only hydrogen gas and oxygen gas in this piston, and remaining outside is called the surrounding. So basically the surrounding is outside from this system, and system means the portion of the universe which we single out, which we take it out where we are going to study about energy. So that is called the system. The surrounding are the everywhere else, and here cylinder, piston and everything beyond. So this is this piston, cylinder and outside atmosphere is called surrounding. System cannot be exchanged with matter with the surrounding, but the system can exchange energy with the surrounding. So once we set up a single system, we cannot take in or we cannot take out any matter, but the system can transform energy from inside to out or outside to in, basically from system to surrounding and surrounding to system. So this type of term we will see some more. Let's understand one more thing. Three type of system there are: system and surrounding. Sorry, these words are overlapping to each other. So basically these surrounding is outside of this bottle. Anything which is outside of the bottle is called surrounding, and system is inside the bottle. So there are three type of systems, which is called open, closed and isolated. So what is the open system? Open system means you can see this bottle have yellow yellow matter and water vapor, and this bottle is open. So that is why it's open system, where and this is yellow thing is a water. So water vapor can go out and in. So basically we can add matter and we can remove the matter, and also heat can go inside and come outside from the system. So that is why this system is called open system. So it exchanges mass and energy both. But in case of if I close this bottle with the lid, so basically we are not in allowing any matter to exchange, only heat can exchange. So that is called the closed system. So open system, closed system, and then third one. So in closed system matter cannot be exchanged, but only energy can be exchanged. In closed system only energy changes, not the matter, but in open system mass and energy both changes. Let's see about the third one, which is an isolated one. So in isolated, neither we can exchange the energy nor the matter. So might be you have remember that thermocol box, or just some bottle which have capacity to hold the water cool for a long time, and if you fill the water hot, it will remain hot. Basically they have two jacket inside, one jacket which hold the water either cold or hot, and then there is another jacket outside, another bottle outside, and that have a vacuum in between, and in between there is a vacuum, so there is no media to transfer or exchange the heat or energy. That is why this system is called closed system, isolated system. And when you will close from the lid, so now that system will become isolated. So in isolated, neither mass or not energy can be exchanged. So as we have seen, the systems are, this slide shows once again the same thing, the type of system: open system, closed system, and isolated system. How you will define in open system: a open system, a region of the universe begins studied that can exchange heat and mass with its surrounding. And second is a closed system, a region of the universe begins studied that can only exchange heat with its surrounding, not mass. An isolated system, a region of the universe that cannot exchange heat or mass with its surrounding. So, and in this system, this is a closed system where we cannot exchange the mass, but we can exchange the heat or energy in this system. So one more thing, that how we measure the energy. So again, the energy definition is the capacity to do work or transfer heat. And so there are two types of energy. One is called kinetic energy, another is potential energy. So kinetic energy, the energy of a motion. Kinetic energy means moving. Anything is moving that have a kinetic energy. The magnitude of the kinetic energy Ek of an object depend on the mass and speed, small v and small m. Magnitude means amount of the kinetic energy is equal to or depend on the mass and speed of the object. So energy of a motion Ek, small k is for kinetic, is equal to half mv square. M is a mass and v is velocity or speed. And potential energy is also called stored energy. Potential energy rises from the attraction and repulsion of the object that experience in relation to the other object. So potential energy is mainly stored energy. Next is the good example of stored energy or potential energy is the nitrogen trioxide. Nitrogen trioxide in the solid form, if you will just hit very small amount, just give a little bit pressure, it explode very fast and it releases its all color. So you can watch some YouTube video about the nitrogen trioxide and you will understand how it releases its energy from the potential energy to kinetic energy or some other form of. So this was about the energy type of energies, kinetic energy and potential energy. Next we will study about the properties of energies.